for recording. And looks like we got one more just dropped down. All right. We had last week for spring break. I took some time off during the week. Unfortunately, it didn't turn out as good a week as I'd hoped because I got my second COVID shot last Tuesday. And that was okay on Tuesday, but Wednesday I had fever from it and was limited from that all day, although then the fever went away Wednesday night. That I was still doing some stuff, but it slowed me down, and slowed me down Thursday because of my body trying to recover from the fever dragging me down Wednesday. And then I've been okay since, but so didn't get that much. And did find the razor last week. Actually before then, because I think I found it at the end of the previous week. And so did on that. So and yesterday that I didn't get a whole lot accomplished, although I did do some stuff. And we got one more there. Okay. So we're down to the last month at this point, because 4 weeks from today, your final exam will be due. And so we're down to the last few chapters. The material actually gets lighter from here on in. You've been through the worst chapters in the book already. So we're on the upper layers, and there's just not that much stuff on the upper layers of the models. So there's not that much to them. This week is very, very light. I was thinking I should have combined it with 14, which is combined with 15 next week, and when I glanced at them, they're both light chapters too, so it really doesn't make any difference. Something's going to end up with a light week on it. So in any event, you've got ICMP this week, which they go through in a very short chapter for you, discussing it, with it ICMP being Internet Control Message Protocol. As a manager on a network, you will use it pretty extensively. That it is a good way for tracing stuff out to find out where you have problems at. As I'm going to talk about for a moment in here, which really isn't covered in the book on it, is there's limitations to the use of ICMP today, and that it's gotten a little bit freer again on use, but it's still limited. It is an abused area. Basically, and I don't know why I'm doing all these in here, but I am. So maybe I'm getting ready to direct a choir or something. But in here, what you're doing with the ICMP messages is you're just determining, is your host reachable or accessible? And that you've got two messages you will use for ICMP, and you may well have already used those at some point along the way. And when you're looking at ICMP, there is a version 4 and version 6 versions of it, but they're not significantly different to you, so you really don't have to worry about knowing the 4 versus the 6 where versus the previous couple of chapters, yes, there was a whole lot of difference between IP version 4 versus version 6. It's still going to be the trace route command and the ping command that you'll use in both cases, and it's just they're going to be a little bit different in terms of what they actually send and what they actually receive. So, and what the codes are, but the codes still essentially are the same. So with that, let's talk about ping first and briefly mention it. Ping is just used to see if you can reach the other device. And all you're doing is you're just sending an echo request to the other device, and that it's a very simple, small packet that's sent across, and it responds back if it gets it. Now, the ping request is a high priority request. So when a ping is received by the other machine, it's a top priority thing to respond to. And that's where we have problems from it. But so you're going to get a response back quickly if it is there. Now, if when you send it, you don't get total responses back of it, normally will send a group of pings of 4 or 5 pings. Is what it will normally do. That when you do a ping, it will actually send out 4 or 5 echo requests. If 1 or 2 of those don't come back, that's not a big problem. They get lost out there on the internet sometimes and such on it. So depending on your congestion and everything else on your network and the other networks it's traveling through, they can get dropped. So that's normally, you're not going to be concerned with that as long as most of them or so get through. And sometimes the first one you try to send out is trying to establish the path and about where the other end is. And so it may well get lost along the way, and then the rest of them all work. And in that case, you're okay. If you're doing the ping command, it's essentially the same on any machine you're going to do it on, basically. Now, Windows just has a basic ping command. You do ping, and you do either the DNS name for the address you're trying to check connectivity to, or you do the IP address for it. If you do it with the DNS name, the first thing that occurs before it sends the echo request is it does the DNS work and finds the IP address and then sends the ping using the IP address. And actually doing ping to a DNS name in Windows will give you the IP address back on it. And I know people that's the way, if they need to find out the IP address for a device, that they'll actually use ping to do it, because it does do that. Okay, so that works for you, and I have actually done that a time or two too, because it was a quick and easy way that I wanted the IP address for something, and I got it real quick from right there. So ping will work with the IP address or with the DNS name on it. So if you're doing ping from within Windows, it sends it, I think it's 4 requests it sends out by default. It's 4 or 5, and I never can remember. I think it's 4. In Cisco iOS, and then in Unix and Linux and stuff, which is what Cisco iOS is based on, you can actually set it to send multiple. You can choose the number of pings of the pings that are sent out. So you can do ping and tell it how many of the echo requests to send. And you can send a massive number of them. And sometimes you'll see Cisco will refer you to doing a larger number. I've seen them suggest for 30 at some points, and I really can't remember what the reasoning was, but You can do bigger numbers when you're working in these others. The command is ping in either and any of the operating systems. So that's basically ping. I'll come back to the defects on it in just a minute. We'll go through traceroute first. Traceroute actually is doing ping also, but what happens is, as it travels along, every router that it touches on, and remember when it touches the routers, because it's a packet, it does get taken apart, put back together. When it's using traceroute, each of the routers it touches will actually respond back to you and give you the name of the router, and that you get the time on it also. And on the ping, it gives you the time of travel back and forth, so you can see how quickly did you contact the other device on each of the echo requests that was sent. Which is one reason, back where I said about sending a whole bunch of them, that was one time we did it, was we were letting it test different routes as it was just generating different routes on it as it was trying to do, and to see difference on speeds and stuff of, did it make any difference as it sat there and ran. So with traceroute, all the difference is every router it encounters, the router will send back a reply also to the sender and tell you which routers it has touched. In the past, that was really helpful information. It's still helpful information today. It will tell you exactly the path that your packet traveled along, so you can find out which routers did it go through. It used to be that most of the routers were all well identified on them by the name of them, and that so you knew where the router was and what it was connected with, and that would definitely. The routers are still usually have some type naming to them that gives you an indication where they are or something else on them, but it's not as much information as was on there identifiable on them. And some of them really aren't identifiable on what you're looking at when you get the message back of what the name of the router is. But with the trace route, with ping, all you know is, can you reach the destination or not? Because if it doesn't come back, then you know you can't reach that destination. For some reason, the destination is not reachable. With traceroute, you can find how far did it go to get there. So did it get out of your network? And looking at the routers it transgressed on the way would tell you, did it get out of your network? Did it get to a larger network that you may be a part of? For instance, when we ping from here at school, and apparently we can now again, it will let you would be able to, with traceroute, be able to know, did you hit the state network, and then did you hit the internet from there? So it will pass on through as it goes on that, and gives you all of that information. So then if it's not reaching the destination, you know where the failure is occurring. Is it something that you control? And back when I ran the network for Swains World Tech, that when we lost internet connectivity, that was the first thing I did, was run a trace route. Once I determined it wasn't within the school, I ran trace route real quick to see where did it go bad. Was it actually not getting out from our router on further on out, and we were running into the state network there too, or was it failing within the state network, or was it failing where? And that told me whether it was something that I could get somebody to work on, or whether it was above and beyond anything we controlled. Because if it wasn't getting out of the state network, then I knew, call or email the state, call the state office and tell them that we had a problem there, and that it wasn't sending out from theirs, and that they needed to look and see what the problem was. And probably I wasn't the only one that was encountering it at the school there. Probably others were too, but that then told them there was a problem occurring. But if it was beyond there wasn't anything I could do about it. It was just sit and wait until wherever it had gone down it, get that straightened out. So traceroute just tells you the route is taking from one location to the other. And if you run traceroute, you'll be amazed on the route that some packets will take. It looks like they've really gone way out of the way, and they're really trying to find the fastest route from one place to the other, which may be much longer, remember, in terms of distance. So you may be sending something to New York from here in Georgia, contacting a server up there, and discover that it actually travels through Los Angeles and back on the route that it takes. So that's what traceroute is going to do for you. Now, traceroute does have two variations to it. If you're using traceroute within Windows, it is traceRT. And that's because Windows comes from DOS. DOS had the requirement on it that commands and file names, which is where the command problem came from, could only be 8 characters, because they had an 8-character first name and then an extension of up to 3 characters, which the 3-character extension we still do encourage people quite often to use, although it's not always used. Sometimes it's longer because they can be longer now. So like JPEG files, you'll see them both as JPG and as JPEG out there. But in DOS, they had to be JPG. But now, once we moved to the more advanced Windows versions, we went to the long file names, just like Linux, Unix, which oddly enough, DOS actually is an off-growth off of Unix, along with Linux is off of Unix, etc. And iOS is actually off of Unix too. That is both iOSs, the Apple iOS and the Cisco iOS. Question of, do you put an uppercase I or whatever in the beginning of the whole thing? And they had a big dispute about that one. So that is the on that. So trace RT is the command in Windows, and all of the others is traceroute spelled out. So TRACEROUTE. But that's too long for 8 characters, so Microsoft went with RT. So that's not hard for you to remember on the difference between the two of them. But both of them are used out there. And Windows has stayed with what DOS had come up with the commands on it, because everybody in the Microsoft world learned those shorter commands. So that's traceroute and ping. Then that's your basic information that's really covered in the chapter for you. They mention about the codes that it comes back with on ping if it's not reachable out there, and that there's a 0, which in IP version 4, the code 0 tells you you couldn't reach the network. Code 1, the host was unreachable. So could you get to the network, or could you not? Or could you not get to the host? How close were you getting? Was the difference in 0 and 1? Was the protocol unreachable? That actually it could reach the network, but that protocol didn't work, which I've not ever seen that one. Or the port's unavailable, and it could be that one, because they could be blocking on that, and I'll come to that in a second. In IP version 6, it's really still the same thing. They just changed the terminology. So that 0 is no route to the destination. Well, that's the network's not reachable, just like 4. And then communication with the destination is administratively prohibited, is the code 1, as opposed to just the host is unreachable for whatever reason. Now that's giving us more specific on it, that we know they blocked it. And I'm going to give you the reasons in a second for that. So their firewall is blocking ICMP messages, basically. And then 3 and 4 actually match back to 2 and 3 in IP version 4 and 2. that they've got in here was a new one that CIST added in, but that's not what's being covered by this book. So they didn't tell you anything about 2. 4 is using the echo request and the echo reply. 6 uses router solicitation and router advertisements. And remember, ICMP is not just being used by us with ping and traceroute by humans on it, but it's also the machines are using that in there, really using the pings that they're using on it, also just to communicate back and forth machine to machine. So ICMP version 6 does in terms of router solicitation and router advertisements, and also does neighbor solicitation and neighbor advertisements they've added in there. So it's a way for the devices to learn about each other. Router solicitation is just where it's sending out and saying, asking who's the other routers attached to my router. Router advertisement is it's sending out and saying, I'm a router on here, just wanted to let y'all know. And so they know about it. Neighbor solicitation finds out what the networks that are attached to the other routers that are attached to our router. And so it learns and builds its routing tables much better with those messages. So it uses the ENS neighbor solicitation to ask what else is attached out there that anybody knows about. And neighbor advertisement is when it sends out the message and says, all right, tell y'all all about that. I'm here and this is what I know. And y'all can use that information. And so that's basically that on it. Now, this part's beyond the book, so you're not going to get asked on the test this, or you shouldn't. That they don't tell you in the chapter on this part of it. ICMP has been abused. Remember, the first thing I told you about on it was ICMP messages are high priority messages because, after all, we just mentioned it's a way to build your routing tables and speed things through your network because they know about everything better. And it's also a way for you to diagnose problems quickly about where's the problem, because you can do a ping on a loopback address to figure out, can you even hit your network interface? You can ping other machines on your network to see, am I able to reach devices within my network? So is it a question of where is the problem occurring? And so you find that one out. You can also ping your network address, and that'll tell you, are you able to just hit the interface going out, not just hit the NIC card? Because if you ping the loopback address, you're hitting the network card, and so you're determining, is my network card, which nowadays is not a separate card in there, but is part of the motherboard, but it's still a separate area on there, is that, can you hit that, or can you actually hit the interface till I've sent something further out, depending on which one you want to use, loopback address or your actual address. And then you can obviously ping on out onto the internet and see how far out can we get. And that's what I would do. Now, you will find people that when they go to diagnose those problems, there's 2 ways you can do on it. Either way works fine. Some people start from close in, so they ping the loopback address first and then go to the network address and then go to another device on the network, and then go out onto further out onto the internet, and then go out to CNN or something. And CNN is one that's used quite often. That's a short name of a host of an address out there on the internet to hit. Doesn't take a lot of using, and you know it's always up, where you don't know on always other servers out there on the internet if they're always up. But you know, CNN has got load balancing, etc., all built in, and they're up 100% of the time. The other direction is people will start from far out and then move in and figure out where the failure has occurred. I've done it both ways. It probably depends on whether or not, when I'm looking at it, of whoever's told me on it, whether I think they may have an idea of why the internet's down. And so I'm probably going to start more likely hitting from CNN. But if I don't, I may well start from their machine of, is their wire just disconnected? Did somebody disconnect the cable to them, or did their wireless access point go down? So either way works fine, and that you see plenty of people go and a lot of people use one way or the other. They start local and go distance, or they start distance and go local. Now, here's the problem with ICMP, and the book doesn't tell you on this, and this goes back to ICMP messages are high priority. Because of that, your black hat hackers, that's a tongue twister almost out of my mouth, black hat hacker, that they determined that you can actually shut down a network or a server using ICMP. Because remember, it's a high priority request, so it comes before anything else. So you can send a ton of pings at a device or other ICMP commands at a device, and it will lock down on it and not be able to respond to other stuff, and locks that network or server out of commission. Because it's sitting there just replying to pings on it. That is called a denial of service attack, or a DOS attack. And you'll see it as uppercase D, lowercase o, uppercase S, normally. Although sometimes they'll mix up on those cases also. But technically, that's what it should be, which sort of distinguishes it from the operating system of DOS, which is all uppercase letters. So that was a major problem, and that you could write a script real quickly. Todd can probably do one for us, and some of the others of you may be able to also write a script real quick in some language, or whatever language you know a little bit of, with just a real simple loop of where it just sits there and loops forever, and the only thing in the loop is just a ping command, and to ping to a specific address. And so now you're firing off pings as fast as your machine can fire them off at the place. Well, the obvious solution on that one was, and I'm just picking on Todd because I know he's working in the computer area, because he nicely shows a picture of us right there that looks like he knows something about computers a little bit. I could pick on one of the others of you too on that too, because some of y'all probably know some scripting language, etc. could do the same thing. Don't do what I'm telling you about right now, okay? Remember, don't do it. If you get in trouble on it and we go to court, remember, this was recorded, and I will play this in court of that I told you don't do it. I'll be glad to send you a postcard occasionally while you're sitting behind bars. I can invest this 70 cents or whatever in a card and a stamp. But you're not going to get to work on computers back there. So what all they did was, if you did come under attack then, all you needed to do was quick block that address coming in, and you were okay again. But it would lock everything down on you, and obviously you could do damage to businesses, and that was done a lot. And that you'll hear, and it's still done, okay? But the solution then was that firewalls got more intelligent, so the firewalls then went, okay, as you used your firewalls, is, all right, we'll just block out stuff coming from whatever spot that is, and we won't have a problem with that anymore. Well, then the hackers figured out a better way to get around this one, because you were just blocking on an address because you didn't want to block everything. And so they started doing distributed denial of service attacks, which means instead we went out there and either got other people to work with us and to all do an attack at one point, or we just went out there and put bots on all kinds of computers, and that you could do that through spyware, etc. and infect people's machines, and it doesn't have anything happens, and that you've got to sit there as a Trojan, and that at a certain point you've set them all to go off at one point, and all of a sudden it's not ICMP request coming in from one location, but from tons of locations. So now you can't just block out that address. You've got lots of locations coming in. So that presented that problem on it and made it more difficult. Well, as you got to the better firewalls, that you went to blocking ICMP traffic. So that it occurs in a lot of cases. Todd said there that Mohawk actually blocks them. The school used to, but apparently from what I had students tell me in this class yesterday, that they said they can actually, they said they had done pings in their other class because they're taking PC repair also on the other days, and that they said Ms. West had them do them, and they had actually worked. They used to be blocked here at school also, that they had blocking completely out on it. However, with our now next generation firewalls, with the more advanced firewalls, you can actually set up your firewall now to let pings through, but block if they're abused. So basically, if 5 pings come in, or it may be 10 pings, but it's a low number, but it's where people can still do that, you'll let them through. But if there's more than whatever the number is set on it of pings from locations, it blocks them from that, and thereby stops the denial of service attacks. But people that are legitimately using it just to see can they make contact with a certain place, because there's other legitimate reasons on it. Y'all are sitting at home working on your homework, and suddenly it appears that you can't get to whatever, so you test to see, can I hit the school's website? And so you need to be able to ping the school's website to see, all right, is it the website's down, or is it the fact that Blackboard's acting up at this point, which is really not at our website, because if you notice it's gntc.blackboard, and it's actually hosted in Atlanta, even though we're using Blackboard on it. It's actually not hosted in Atlanta. We're actually hosting on AWS. So you're actually hitting out on AWS, is where Blackboard's sitting. So hopefully it doesn't go down. So with the next generation firewalls, that you can then open it back up. CNN has definitely opened up for several years and allows that again, because they've got the firewall set to allow it, and that they allow again. That's another reason to use them as your one of out there on the big internet of checking. And like I say, now the school is allowing on it too, but we now know that doing a ping on a Mohawk address, that we're not going to get anything back. It's going to tell you it's unreachable, but it's that the protocol was blocked, actually, is what the issue is, which ICMP 6 is going to give you a little bit better if you were to actually look at the codes on it. Because it also gets you an idea of how speeds are working out there, etc. And if you do a speed test, actually that's what it's doing, as it's clocking it away on it, is using the pings also. So ping can be a really useful tool for us, but ping can also be a very abused tool, okay? And so just be aware of that. For the test in here, because they didn't mention any of that that I saw in the chapter on it. Maybe I overlooked it. And that is another use of it right there too, Felicia. That's really handy on it too. And ping happens to be, I'll mention this one last on it. Ping is a command that is not an acronym for anything. That is actually a word out there, as in ping pong. Because if you think about what we're doing with ping, we're playing, that ping is working just like in ping pong when you play the table tennis game. That you're hitting the ball to the other side and getting the ball hit back to you. And we've just done exactly what we've described with ping on the computer network. So ping is not an acronym for anything. That's a different one for you. Another thing to make this chapter a little bit easier, ICMP, as I have mentioned a couple of times, is an acronym for something, Internet Control Message Protocol. But ping's not. So and I have actually seen a question on something that about ping not being an acronym. I've also seen somebody try to come up with an acronym for it, and I'm going, no, it's not an acronym for anything. When they came up with ping, and ping dates back to at least the development of Unix, and I really think ping dates on back from what things I have read. I think ping is a command in some format or another that dates probably on back to at least the 50s. And to a degree that the telecommunications industry has used a similar command on it too, because they electronically will send an electronic signal across telecommunication wires and then wait for it to bounce back at them also, just on a sound wave sent across on it, and that they're doing a ping there too. But I'm glad that helps on that, Felicia. And I usually try to mention about ping pong on it early on, and I just forgot about it till then. So be aware of all of that. If you go on and you take a certification test, the abuse could come up in terms of there. However, in here, that Cisco elected not to mention about abuse on it. But I think it's important to mention to you. However, I know other instructors that are going, oh no, don't say anything about how it's abused, because then you're telling students how to go out and do. Well, we teach cybersecurity here, and some of you are cybersecurity students. And that's when we've had a hard time convincing the school, and apparently we finally have, in terms of that we got to be able to use ping, that we got to be able to use the abuse things too here for people to be able to see how to protect on all the different things. And that you got to, if you're going to be a really good white hat hacker, you got to know the black hat hacking to be able to do it. There's just like a policeman, a really good law enforcement officer, be it police, FBI agent, whatever. If they're a really good one, they have an understanding of how the criminal's mind works. So that's why they are able to, the really good ones, solve crimes much quicker, is that they understand on that, and that then that helps them get in and figure things out much quicker or deal with situations. It's the same thing here for y'all. All right, any questions for me? I really ran a little longer than I thought it would, but it's about the same amount of time it took me to go over the chapter yesterday in person with the class, because we've taken about 40 minutes. So let's say this is a much shorter and simpler chapter for you this week. You do have a test this week. I don't remember if you've got a lab this week or not, because some of these later chapters, I think, skip on labs. Let me look at the calendar real quick. And yes, you do have a lab this week also. So you got a test and a lab to do, which I would have thought you would have a lab to, because these are two easily usable commands to use, and just using within Packet Tracer, or if we were working in the lab on the real equipment, that you could obviously ping between the device you're on and the router or switch you're connected to without going to the outside when we used to get blocked on it. That's when we'd find it out whenever I was using the real equipment, and that one of the steps that they'd be wanting them to do would go out and they couldn't go out with it. Because they had it blocked well on it. So now I'm not sure, because if you do ping, it's going to want to, if you do ping google.com, it's going to return an IP version 4 address to you. And that's going to try to use IP version 4 before it sees 6. And there's not a ping v6 versus other things, or at least if there is, I am not aware of it. I think we'll just gradually adjust that. If it can't find a 4, it goes to a 6. But as far as finding a 6, so it's saying ping and then say IPv6, and that would give you a 6. I have not tried that or done anything on it, so I don't know on that. I might look around on that because I'm a little curious also when you just said that I've not really thought about it in terms of it. Because until the last couple of years, there wasn't really much. If you wanted to find your IPv6 address, obviously use ipconfig, but as far as doing it otherwise, I'm not sure. So when you did ping IPv6, it's going and pinging IPv6. It thinks that's the name of the site that you're hitting at. I have to look it up. If I find that answer, I'll put it out there in the class for y'all, because I'm a little curious too. All right, the rest of y'all, have y'all got any questions? And Sylvia, you're in here right now, so I'm going to go ahead and throw this. I have not received that form. If you will drop me an email and tell me where you left it at, I can double check on that to see. All right, if there's not any other questions, I'm going to go ahead and stop the recording.